Okay, recording has started. You should be able to see my daily agenda, me hanging out with my sunglass emoji best friend next to me. It is Thursday, September 10th, so happy Thursday. We only have one more day to go after today until it's the weekend. So hopefully you have some fun plans to get away and do something nice and relaxing for the weekend. We're almost there. Today, our plan is to finish up our lesson from yesterday on factor pairs, right? We drew some colorful rectangles and rainbows that connected numbers together, and we're going to finish up the discussion today. Then we'll get into the lesson that follows it on prime and composite numbers. Now, you might have heard the word prime for prime numbers, but we're going to go into a little deep dive on it over today and then probably early class tomorrow as well. So we'll finish that. Our target for today is determine whether a given whole number is prime or composite using rectangles. Right, I highlighted and underlined those prime and composite words because those are kind of the key words for today. Although we really probably won't get into it until tomorrow. We're still finishing up those factor pairs. So the last bullet, find the factor pairs of a given whole number. So that's what we've been working on with those rectangles. The homework, again, as I said earlier this week, this middle part of the week, we won't really have homework because we've been doing a lot of our work in class together as a group. I want to make sure that you have a good foundation of these concepts before just giving you homework to complete it on your own, especially with the limited time that we have for instruction. So I will post this probably tomorrow, but again, this will be in class. So let me stop sharing and let's start sharing the other screen. So there's my calendar that you should see. I'll get OneNote up. Okay. Do you see a bunch of colorful rectangles and rainbows? All right, awesome. So this is what we did all day yesterday. Excuse me. We started off with, I'll scroll back up, this how many rectangles activity, where I gave you a list of rectangle areas. So those are all areas of rectangles, and it's our job to find all the rectangles that have an area of 16, and all the rectangles that have an area of 11, and all the rectangles with an area of 25, and so on. And so I scrolled on down, and this is what we came up with. I color-coded it so it's hopefully a little bit easier for you, but you can see 16's in blue, and we found 3 rectangles that make an area of 16. We have 11 in green, we found 1 rectangle. Red 25, we found 2, and so on, as you can see. We also did these little factor rainbows to help show, what 2 numbers for side lengths are we using to get that area. Because remember, we can take side lengths of a rectangle, multiply them together, and give us the area of the entire rectangle. So in blue, this rainbow here is matching up all the numbers that when multiplied together give us 16, which we talked about factors a little bit, but let's go ahead and at least I will write it down that these are called factor pairs. Okay, a pair, not like the fruit. Just a second, you might lose my screen. I have to let Elizabeth in. Yeah, this isn't pairs like fruit. Think pairs like 2 people, like a pair of people, or a pair of markers. You have 2 markers that come together, a pair of pins, right? You're thinking of 2 things that are grouped together. That's what pairs means. So when we talked about factors, we said that factors are things that are multiplied together to give us a product. Well, factor pairs are the grouping of those 2. So 1 and 16, that's a factor pair. 2 and 8, that's a factor pair. 4 in itself, because you multiply 4 by 4 to give us 16, is another factor pair of 16. Okay. Let's go ahead, and if you're in your workbook, page 7 is this next page here. Okay, page 6, or excuse me, it'd be page 9. So if you're in your packet, then yes, it's page 7. If you're in your workbook, it's page 9. And it says, how many rectangles gallery walk? And so remember yesterday when I said, oh man, I wish that we were in class because you would all make posters and we'd walk around the room and take this gallery walk and see all the different shapes up on the wall and come back together and talk about it. Unfortunately, we can't do that. So change it up a little bit. But what we're going to do is follow these directions and kind of just basically notice, talk about the things that we notice about the rectangles and the factor pairs, and what we notice about the areas of different numbers, things like that. So let's read these directions then. Describe what you notice for each area. So what do you notice for each of those colors? Use the following sentence frames when you share. Well, I noticed some of the areas ... I noticed the rectangles for numbers blank and blank are similar because. So we're going to talk about those areas and talk about maybe a couple areas that look similar when we're talking about the rectangles. So in general here, I'll just open it up for the room. What are some things that you notice about these rectangles? I'll zoom out a little bit so I can get factor pairs written up there. There we go. So what are some things that you notice about these rectangles? It could be anything. Rectangles or the factor pairs. Does anything jump out? Are there areas that give us similar types of rectangles? Eileen, saw your hand was up.
So like, what do I notice about the rectangles?
Yeah, does anything stand out about the rainbows that we made that connects the numbers, or certain areas compared to another area? Just anything that you see jumps out.
I noticed that some rectangles are wider and some are not.
Okay, so we have like this 1x16 up top is really short, flat, and really long, whereas we have a 4x4 that's square here. Okay, but it's interesting that they have the same area, right? Because we found rectangles that have an area of 16, and those were 2 options. And we even have 2x8 here, which is a little bit different shape too, or size, but it has 16 inside as well. So that's interesting. Okay, thank you, Eileen. Does anyone else want to share something that they notice? What do each of these factor pair rainbows start with and end with? So these rainbows over here. Adelina, what do you notice about what they start and end with?
I noticed that they start with a 1. I literally just noticed that all of them, I think all of them start with a 1.
Yep, they do. Remember when we were making rectangles yesterday, I said there's one that's a given, like it's always the easiest one to start with. And I said, draw one that has 1 row and multiply it by the number that we're trying to find the area of. Because whenever we multiply something by 1, we get that number we're multiplying 1 by. So 1 times 10 is 10. 1 times 16 is 16. 1 times 25 is 25. Right? So when we're looking at factor pairs, we'll always start with the 1, and it'll be matched up with the number, the area that we're trying to find, right? Okay, so all of them start with 1. Very cool. What do you notice about the areas of 11 and 5? What's going on there? Malia?
They are 11 and 5. They have like the 5 for the area is 5. They're both have
their own number for the area.
Okay, very true. They each have their own number for the area. How many rectangles could we make for 11 and for 5, Malia?
1.
Yeah, we could only make 1. There was no other, like we couldn't try 2 times something to give us 5. That wouldn't work. 3 times something doesn't give us 5, at least whole numbers, right? So it is kind of strange that 11 and 5 only have that 1 rectangle that we can make. In fact, it's so interesting and important that we actually have a name for it. We'll get into it maybe at the end of class today, maybe tomorrow, but I'm going to write it down anyway. These are prime numbers. Yep, you can write it down. These numbers that only have 1 rectangle that they can make, or 1 factor pair, those are called prime numbers. Okay, and I won't go into too much detail on it right now because we're going to talk about it either at the end of class today, after the next activity, or tomorrow. But that prime and composite numbers, that's what we're seeing right here. These prime numbers are this 1 and 11. That's the only factor pair that can be make 11 for an area of a rectangle. 1 and 5 is the only factor pair that we can multiply together to give us an area of 5. So anytime that we have just the number times itself is the only option, that's a prime number. And we'll get into more of that later. Is there anything else that we notice? Let's think. How many factor pairs are there for 25? So in red here, how many factor pairs are there? Adelina?
25 only has 1 factor pair.
Okay. What about for the whole? So 1 and 25. Yes, that is 1 factor pair. But what about 5 in the middle? That's another option, isn't it? 5 times 5.
5 times 5. Yeah, that's true.
Because we have 1 times 25 and 5 times 5.
Yeah.
Right?
So,
those are 2 options here. So if those are our 2 options, how many factor pairs are there?
2.
Yeah, there's 1 factor pair there. There's 1 factor pair there. We can also notice that there's only 2 lines, arcs on the rainbow, right? There's only 2 things being connected. Yep. 1 and 25 and 5 and 5. We can also look at the rectangles here, and there's 2 rectangles too. Right, so those should all match. Number of rectangles, number of arcs in the rainbow, and number of things that are being multiplied together to give us 25 should all match. And so therefore, there are only 2 factor pairs for 25. Okay, if we were to do, I'm going to scroll down. If we were to try to find all the factor pairs of 12, how would we do it using the rainbow method? And what would they be, and how many factor pairs would we have? So let's take it one at a time. What are the factor pairs, first and foremost? Of what I say, 24 or 12? 24? 12? 12. Malia's giving me 1, 2. Okay. Oh, my light's going off. How would I find the factor pairs of 12? How can I find the factor pairs of 12? Well, looking up here, what did Adelina share that all of these factor pairs start with? They all start with the same number. What is that number? Adelina?
The first number is 1.
Yeah, it's always 1. Remember, we can have 1 and the number always. And if we're looking at 1 and 12, there's one match right there. There's the start of our beautiful rainbow. Eileen?
Do we have to write it down?
I would like you to. Yeah, we're just going to do this one factor pair. I think it'd be a good exercise for us. So we have 1 and 12. I'll write out the multiplication too. 1 times 12 equals 12. The next thing we did was starting at 1. Well, now we go to 2. Let's see if 2 is a factor. Can we multiply 2 by a number to get 12? Can we multiply 2 by a number to get 12? Leah's shaking her head no. Well, the nice thing about this is that we can skip count to it and check. Okay, so if we were looking to see if 2 is a factor of 12, well, let's try it. 2, 4, 6, 8, 10, 12. Oh, yep, there it is. All right, if we skip count by 2, we get to 12. How many times do we skip count? Well, here's the first one. Here's the second, third, fourth, fifth, sixth. So 2 times 6 will give us 12. So there's another factor pair. You guys see how I did that? Does that make sense? So we start at 1, we match it with the number that we are trying to find the factor pairs for. Then we try 2 and match it with the number that could be multiplied by 2 to get us to that number. Possibly, sometimes it can't. And we just keep going. So let's try 3 now. Can we multiply 3 by a number to give us 12? Malia, see your hands up. What can we multiply 3 by to get 12?
4.
Yeah, 4. Exactly right. 3 times 4 equals 12. And since we there's no numbers between 3 and 4, this is our last one. We know for sure that that's the last one that can be paired together to make 12. So, given this information now, how many factor pairs are there for 12? How many factor pairs are there for 12 now that we've completed this exercise? I want to see some more participation, some more hands. Either more hands telling me the answer or more hands telling me I'm confused and I need some more help. Tania?
A factor for 12?
Yeah, how many factor pairs? So how many groups?
A 1 can be a factor pair to go to make 12 with a different number.
Okay, so we have 1 and 12. That's one factor pair, right? That's why we connected the rainbow from 1 to 12, because when multiplied together, 1 times 12 is 12. So there's one factor pair. So if I'm asking how many factor pairs in total, how many?
3?
Yeah, great job. There are 3 factor pairs. There are 3 lines or arcs connecting things in the rainbow. There's also 3 ways to multiply whole numbers to get 12. Right? There's 1, there's 2, there's 3. If we decided to draw rectangles, we'd have 3 rectangles as well. They always match together because it's pulling from the same information. All right, good job, Tania. Are there any questions on this? On what a factor pair is? How we find out how many there are? Can I see thumbs up, sideways, down? possible? Okay, Malia says good. Eileen's kind of sideways. That's okay. Katie's up. Okay. Okay. Well, let's go ahead and, well, first, do we have questions on it? For those who are kind of sideways, is it because you don't understand it, or you just need more practice with it?
I just need more practice on it. I don't have any questions.
What's that, Adelina?
I just need more practice on it. I don't have questions on it, but I get it, but I just need to practice it more.
Okay, well, that's good. So then tomorrow I might have a couple practice problems for you guys to do then. All right. But if there aren't any questions, then let's go ahead and move on to the next activity. Okay. So you won't quite do the card sort yet. That's probably going to be tomorrow. But I want to go ahead and start with a kind of warm-up entry activity that would be for tomorrow's exercise. I want to do it today because I think it's really good pulling together what we did last week, or this last few days, sorry, on multiples. Okay, if I were to skip count by 2, it would look something like this, wouldn't it? Let's see. I have 0, is that going to show? Yep, right there. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Okay, so that's skip counting by 2 all the way up to 30. Now I'm going to skip count by 5s. That's okay, Elizabeth. I see your chat. 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. Okay, so these are the numbers. You can write this down if you want in the margin on the side, if you have some room. What I want you to do is looking at each of these columns, either together or on their own, so each one separately. What are some patterns that you see? What are some things that you notice? Does anything jump out? So I'll give you maybe a minute or so to think about that. Look for patterns on each side. Maybe look for patterns between the two of them. And then I want to hear your thoughts in about a minute or so. Okay, and I want to hear more than just Malia. I know Tania's been involved too. Eileen, Adelina. I want to hear some new voices. So when you're ready, go ahead and put your hand up. What are some things you notice? What are some patterns you see? Very good. I see a few hands already. That's awesome. Malia asked if this is on the workbook or the packet. I don't believe so. I think in the workbook, they left you a blank page right before 3.1 or activity 3.1. I may be wrong. I don't have the book right next to me. You can do this on a separate sheet or just in the margin too. All right, so let's hear from a few people. Let's start with Tania here. What is a pattern you see? What's something you notice?
I noticed that the skip count by 5s and the skip count by 2, they both start with a 0 and it's different color.
Okay, so they start with a 0. That's kind of interesting. I'll circle the zeros. Yeah, I'll start at 0. They have different colors. They skip count. All right. Thank you, Tania. Malia, is your hand still up from earlier, or do you want to share? A pattern that you see.
It was up from earlier. I forgot to put it down.
Okay, that's okay. What about you, Elizabeth? See your hands up.
I see on the first one that it's like 2, 4, 6, 8 each time. Like 2 skip counting.
That we're skip counting?
Yes, skip counting by 2.
Yeah, so we're skip counting by 2 each time. So +2, +2, +2 as we keep on going. Okay, thank you. Eileen?
I was gonna say that, do we have to do like circle the stuff?
You don't have to.
Okay.
I'll tell you when you need to circle something because there is like a main point to what we're doing here.
Okay.
Yep, Daniela?
That the second one, it shows that they're counting by 5s.
Okay, so on this side, we're going +5. Okay, here's a question for you. Are there any of the same numbers on either side? Do they share any of the numbers? Camila?
Yes, because on ones, at the last one, it says 30. And on the other one, by counting on 5s, it also says 30.
Okay, are there any other ones that are similar to the same?
10 and 10.
You say 20 and 10? Yeah, so they share a few numbers then. They share 0, 10, 20, 30. How many times do we have to skip count by 5 to get to 10? Daniela?
5.
How many times do we need to skip count by 5 starting at 0 to get to 10?
2.
Yeah, 2 times. There's one there. There's one there. Right? We could think of it as, 5 plus 5 gives us 10. Oops, that's 10, not 16. Oops, there we go. So that gives us 10. Well, last week we brought up how when we're adding the same group repeatedly, it's the same thing as multiplying, isn't it? You can treat it as multiplication. Because this is the same thing as if I were to draw a rectangle with 5, that's supposed to be 5 down there. I'll redraw it real fast. So there's 5 there, and we're adding it together to 5 there. Right, 5 on the side for rows, 1 column. Well, that's the same thing as a bigger rectangle. That's a 5 by 2, isn't it? If we add those single columns there and there, it can come together to make one wider, 2 column wide, 5 rows rectangle. And we said when we're finding the area of a rectangle like that, well, that's the same thing as multiplying one side by the other. Are you following me so far? Okay, awesome. So if I went over here, and now looking at the red column for 2's, how many times do we need to skip count by 2 to get to 10 if we're starting at 0? Daniela, go for it.
You need.
And skip counting by 2 on the left side. You say 5?
Yeah.
Yep. 1, 2, 3, 4, 5. There are 5 jumps. I'm going by 2 to get from 0 to 10. So we have 2 plus 2 plus 2 plus 2 plus 2 equals 10. And in the same way that we did up top, you can think about it as adding groups of 2. And if we group those rectangles together, I'm actually going to do it down here. We'd have 2 rows and 5 columns, right? And just like up here with the 5 times 2, when we have rows and columns that make a rectangle, we can multiply those rows and columns together to give us those, the area of that rectangle, right? Now, it's not just a coincidence that 10, 20, and 30 fall in the same, that skip counting by 2 and 5 falls on 10, 20, and 30 together. That's not just a coincidence. Remember we said that the product, we have that keyword multiple. I'll write it down here. Remember how that was the key word the last couple days? We were talking about multiples. Okay.
Yeah.
These multiples, right? 10 is a multiple of 2 because we can multiply something by 2 to get us to 10, like we did over here. 10 is a multiple of 5 because we can multiply 5 by something to get us to 10. Well, the fact that they share 10 as multiples and they share 20 as multiples and they share 30 as multiples, we call this common multiples. Common meaning that it's the same thing. They share the same number. So each of these numbers in a column are a multiple of the top number here, 5, or a multiple of the top number here, 2. But these numbers that they share together are called common multiples. And that's not a vocab word for today. It's just a special type of multiple that we talked about yesterday and the day before. And I want to make sure that we kind of covered that as well. So one last thing, I'm going to leave it at this because we're a little over time. What are some other common multiples that you could think 2 and 5 would share? So we listed 0, 10, 20, and 30. What are some other common multiples you think they have? Camila?
5 times 1.
So 5 times 1 up here. Can 2, or is 5 a multiple of 2? Can we multiply 2 by something to get to 5?
No.
No, we don't get a whole number. We can't multiply 2 by a whole number like 1, 2, 3, 4, 5 to get us to 5. So unfortunately, 5 isn't a common multiple. But Camila, I'm going to ask you one other question. Do you see a pattern with the numbers that are in common here? You see a pattern with the numbers that are circled, Camila?
Yeah.
Okay, what's the pattern?
That they mostly have some of the same numbers.
All right, what same numbers?
10, 20, 30, and 0.
Okay, and what? How much space is there between 0 and 10? Or what's the jump from 0 to 10 and 10 to 20 and 20 to 30? What's the jump?
Should I do both or just one?
Well, they should be the same, wouldn't they? What's the jump from 0 to 10? How many numbers?
10.
Yeah, and what's the jump from 10 to 20?
10.
Yeah, and then it's the same jump from 20 to 30, right? So
Yeah.
we jump by 10 each time. Oop, I think my Chrome or my laptop just died. So yeah, 40 could be one. 50 would be one. Do you have any other guesses on what the other ones could be that's listed here?
20, 30, 40, 60.
Yeah, 60. And are there any other ones?
70.
Yeah, 70 is the last one that we have listed here. But yeah, there's a pattern here. All right, it's jumping by 10 each time, in this case, for 2 and 5. All right. Do you have any questions on this? Remember, this is called common multiples. So multiples that numbers share. Are there any questions on common multiples or multiples in general? Or the factor pair rainbows that we made with all the rectangles? Is it making sense? Okay. So this is where we're going to stop today. Thank you for paying attention for a little bit longer class period. I'm going to go ahead and stop the recording real fast, and then I will